Hello, my name is Mateusz, and I'll tell you how I designed and installed a HRV system in my house.
The building itself consists of an older section and a newer part, both of which are physically connected. From the very beginning, the existing ventilation system was simply not adequate, so I had to start searching for an effective solution. I was considering improving natural ventilation, wall-mounted heat recovery units, or a mechanical ventilation system with a central unit. Inspired by many videos about DIY HRV systems, I decided to take on this challenge. I hope that everyone else who also has an old house and is considering improving their ventilation will find a lot of helpful information in this video. Due to the large space available in the attic, I started designing by determining the duct route. This was most challenging in the new part of the house, where I had to run the ducts along the walls beneath the ceiling. For the installation, I planned for 90 mm outer diameter ducts. In the plan, I took into account that channels from the same distribution box should have the smallest possible length differences. The calculations are only approximate, and I decided on CWPP 420 units. One of the challenges was adapting the attic space. We managed to clean it out and insulate it so that it would meet the requirements for a technical room. Another challenge was the construction of a new section of the house, specifically the openings for the expansion boxes. This task couldn't be completed without the use of heavy equipment and the precise cutting of reinforcing bars. We are now in the living room and we're looking at the ventilation boxes. On the right side there is the southern one, and on the left side the northern one. Now we are looking at the exhaust ventilation box, which is located right above the fireplace. She managed to install it from the top without having to demolish any of the surrounding walls. We are now moving into the hallway, where we can see the air distribution box.
Into the corridor.
And additionally, on the other side, within the vestibule, there is an exhaust air box, which also features a recirculation option. On the right side of the expansion tank, we can observe pipes that are used for the transport of chilled water, insulated with a 25 mm rubber insulation layer. Next, we're moving to the other side of the building, to the bathroom. Unfortunately, we could only install the box with a single channel, but the bathroom is no more than 9 cubic meters in volume. In the kitchen, we managed to install an expansion box with 2 channels.
The positioning is dictated by the ductwork running through the upstairs bedroom.
For insulation, I used classic expanding foam, gun foam, leftover styrofoam, and mineral wool. We're now heading into the dining room, where the air supply ventilation box is located, and it also has 2 separate channels. We're now going to move up to the room situated above ground. As you can observe, I was forced to run the ventilation ducts along the wall, just beneath the ceiling. This was the only truly sensible and viable solution that would allow me to successfully extend these ducts into both the bathroom and the kitchen. I think that losing a little space and a bit more effort building this with drywall is worth it, so that the bedrooms have fresh air from ventilation. Taking into consideration some practices for ducting arrangement, this particular section within my setup could potentially create the highest resistance. Once the ducting was carefully inserted into the void above the stairwell, I then applied a generous amount of expanding spray foam and mineral wool to ensure it was thoroughly insulated from the upper side. On the right side, there's a double wall, and right behind it are the supply and exhaust boxes.
At the very farthest point of this enclosure, you can clearly discern the presence of various channels which are specifically designed to lead you towards the northern room and also to the adjacent dining area. Here, we're observing the recirculating extractor fan that's located above the staircase. As the south-facing room, I made the decision to insulate the entire space,
The junction of the ceiling and the adjacent side wall.
I was also considering running channels up high above the ceiling, but the actual distance between drywall, board, and fixing is much too low, and it would not make it possible for proper insulation. We are now in the attic. I have indicated with purple lines the routes of the supply air ducts for the northern and southern living rooms. They are situated beneath the floorboards between the supporting beams. To insulate the majority of the ducts up in the attic, I utilized a few channels that were part of the DGP system. In the area marked by the purple line, the exhaust duct from the living room runs.
And
This area will be designated for the main ventilation system, including a recirculation fan and a combined cooling and heating unit. From the right, we can clearly see the exhaust air ventilation box. On the left, we have the primary air supply distribution box.
And directly ahead, a concealed exhaust unit with a recirculation option. The ducts are already partially enclosed here.
I made an effort to get additional insulation.
so
Due to its horizontal placement, I will consider a long throw directional diffuser here.
The air intake and exhaust are located on the attic's northern wall, maintaining an 8-meter distance from each other. The air intake is on the west and the exhaust on the east. The wall's thickness prompted me to construct wall sleeves for both the intake and exhaust. For the drainage of condensate from the recuperator and the chiller, I have installed an additional wastewater pipe, which is 32 millimeters in diameter.
so
To complete the installation, I still need to preserve the attic floor. Then I'll be able to move the recuperator, the fan, and the cooler and begin the actual assembly of the central unit. I am presenting to you the most probable version of the layout for the attic space.
I definitely want to automate the recirculation damper.
And if it's not possible to implement a bypass, then I will opt for the exchanger.
Led with the weak points of my heat recovery ventilation system. First, there's the complete inability to install a larger number of ventilation ducts, particularly on the very narrow wall sections. A further critical issue involves several extremely sharp bends in the ductwork, which will inevitably increase air resistance and, as a result, significantly complicate the precise regulation of the entire installation later on.
Regarding the factors that truly favor heat recovery in my home, one of the most significant is that the house recently underwent a complete thermal modernization. It's now well insulated, has new airtight triple glazed windows and doors. There's also a more efficient heat source that will be able to work perfectly in conjunction with the heat recovery system. Of course, I'm referring to a heat pump.
Another key benefit is the general space in the attic, which means I'll have unrestricted access to all the installations for any necessary maintenance.
The house is equipped with relatively small windows, a design choice that significantly reduces heat loss in the cold winter months and similarly minimizes the escape of cool air during the hot summer.
Despite the rather low ceiling height in these rooms, I successfully managed to install 90mm ventilation ducts. This is another significant advantage, and also the fact that between the heat recovery unit and the living spaces, there's an additional 15mm of wool insulation, which provides excellent extra acoustic soundproofing. In summer, the annoying problem of insects inside the house disappears. In autumn, the issue of excessive dampness in the rooms vanishes, and in winter, the troublesome problem of icy cold water disappears.
I wouldn't have been able to do all of this without the help of my immediate family and friends. I'm very thankful to Mr. Piotr for the inspiration to take action.